Alright, welcome to Chapter 4, Section 4, Parallel and Perpendicular Lines. This is something you've already visualized in class or last year, but we're going to go through the math that guides whether two lines are parallel or perpendicular. So, first definition, parallel lines. Two lines are parallel if they have the same slope and they never cross, which typically means that they have a different y-intercept. That's the way that you can identify that they're not going to cross. As opposed to overlapping lines, which are also parallel, two lines with the same slope, but they actually have the same y-intercept, which means really they're not even two different lines. They're just two different equations that model the exact same line. So two parallel lines will have the same slope going in the same direction, but have different y-intercepts, whereas overlapping lines, even if the equations look different, when you actually graph them, they are right on top of each other, so they're really the same line. The other possibility is perpendicular lines. This is two lines that intersect at a right angle, which is 90 degrees. And so their slopes are going to be the negative reciprocal. So for example, if one line has a slope of 2, the slope of the perpendicular line, and a little upside down t like this, is the symbol, the math symbol for perpendicular. So if m original is 2, then m perpendicular is negative 1/2. So it's a negative reciprocal. That means you flip the number, flip the fraction upside down, and make it negative. Okay, problem solving tips. When you're searching for a parallel line, the first thing you want to do is find the slope of the old line, and then note or realize that the new line has the same slope. So m new equals m old, right? And then once you know the slope of the new line, you can use whatever other information is given to find the equation. However, when finding a perpendicular line, first you find the slope of the old line, and you find the slope of the new line, which is perpendicular, is negative 1 over the slope of the old line. So negative reciprocal. Flip it upside down and change the sign. And again, once you know the new slope, you can use that new slope to get the equation of the new line. And then let me go back to these definitions here. So lines could be parallel or overlapping, and they could be perpendicular. Really, these are both kind of rare. In most cases, the lines just cross. So they're not parallel and they're not perpendicular. They just cross with some other angle. So the angle may be not 90 degrees, but this is just a normal situation. And it's kind of a special case where they're parallel, or a special case when they're perpendicular, and an extra special case when they're overlapping. Okay, let's find a couple of examples for finding parallel and perpendicular lines. So this is a very standard way that problems will be written both in your textbook and maybe on your homework and quizzes. Find a line parallel to this line that goes through this point. So imagine we have some line right here. Okay, there's our line. And we have some point right here. So visually it makes a lot of sense. We're trying to find this dotted line that's parallel but goes through a certain point. So how do we do that? We need to find the slope first. So we need to solve this equation for y to get the slope. So we can subtract 4x. Here, let me just rewrite it real quick. Minus 4x, or 4x minus 3y, equals 8. So we're solving for y. Minus 4x minus 4x, negative 3y equals negative 4x plus 8. Now divide by negative 3, divide by negative 3. Y equals positive 4/3 x minus 8/3. Okay, negative divided by negative is positive. So my slope is 4/3. So m of my parallel line, this is a symbol for parallel, two little lines at an angle, is 4/3. Okay, that's really, really important. And my point is 3, 2. Not that. 3, 2. Okay, so once I know the point and the slope, I can write the equation. Now remember, back a couple sections, we learned there's two different ways you could proceed. You could start with y equals mx plus b, plug in the point and the slope to find b, or you could just write the equation in point-slope form. So I'm going to opt for the second one because it's a little bit quicker. Y minus y1, which is 2, equals m, which is 4/3, times x minus x1, and x1 is a 3. So there's the equation in point-slope form of the line through the point 3, 2, through this point 3, 2, that's parallel to the original line because it has the same slope, 4/3 here, 4/3 in the original. Likewise, you could plug this stuff in over here. You could plug in 2 equals 4/3 times 3, that's my m and my x, plus b. Now, 4/3 times 3, the 3's cancel, so I just have a 4 here. Minus 4 minus 4. So negative 2 equals b. So my equation would be y equals 4/3 x plus, minus 2. That's a minus, a nasty minus. So these are the same equation. These are the same thing. Whichever one you want to express depends on how the question asks you. Does it say put the answer in point-slope form or slope-intercept form, or does it not care? Alright, one more example. Find a line perpendicular to this line that goes through the point 1, 8. So we need to find the slope of the perpendicular line and the point that it's going to go through. Once we know the slope and the point, we can make the equation. So 1, 8 is our point. How do we get the slope perpendicular? Well, let's look at the original line. First of all, what form is this in? It looks to me like it's in point slope. Y minus y1 equals m x minus x1. So by comparing the equation that we're given to the formula, we can see that the slope here of the original line is negative 1/3, and the slope perpendicular is negative 1 over m old, right? So the old line is negative 1/3, so the new line is positive 3. I flip it over and I change the sign. So I can make my equation y equals mx plus b, plug in my numbers, 8 equals 1, that's the point, the x-coordinate, times the slope, which was a 3. Actually, I got these two backwards. Really, m is 3 and x is 1. The order doesn't matter, but just for conceptual clarity, there's my x and there's my m plus b. Okay, 1 times 3 is 3, so I can subtract 3 from both sides. And I get 5 equals b. So my equation is y equals, my slope of the new perpendicular line is 3 times x plus my b value, which is a 5. Now, sometimes I use a lot of space when I'm solving these equations because I want to show what I'm getting, show my work on how I got there, and then get my answer. So I encourage you guys over and over, don't try to cram these in on your homework. Use lots of space, it's totally okay. Space it out, leave space between one problem and the next, etc. But that's how you find your parallel and perpendicular lines. Just remember, parallel is the same slope, and perpendicular is the negative reciprocal, and anything other than that, and they are neither parallel nor perpendicular, which is just a normal two lines crossing.